Hi, today we are just going to talk about the core concepts of Rust. Here are five very important topics: ownership, borrowing, lifetimes, traits, and concurrency. Some of these are very unique to Rust, and we will explore them briefly in this tutorial. Each value in Rust has a single owner. When ownership moves, the previous variable can no longer be used. Let's look at an example here. String s1 equal to string from hello, and then string s2 equal to string s1. So when we do s2 equal to s1, the s1 is no longer valid because it is moved into the s2 variable. So if you try to print the s1, it will result in a compile error. It is very important to watch out for this type of compiler error, which is mainly done by the borrow checker. Now let's talk about borrow checking. There are two concepts here: borrowing and references. Borrow can be done with ampersand type symbol, and that is considered an immutable borrow. And you can also borrow using ampersand mute t. This gives you a mutable reference, and it also prevents data races at compile time. Let's consider the example of an immutable borrow. Uh, Print ln is taking the parameter of a string, owned string, and then is trying to print the length of the string. If you can see in the parameter for print ln, there is an ampersand string. That indicates that this function is taking a immutable reference to a owned string. And then you have the mutable borrow. In this function, push exclaim, it's taking a parameter s, which is a mutable reference to a owned string. And here we are pushing an exclamation point to the end of the string. So that's why it's mutating the string that is being passed in. So you need a mutable reference for this particular operation to compile successfully. Now let's talk briefly about lifetimes and traits. Lifetimes ensure references are always valid. Traits, on the other hand, define shared behavior and support generics. Here is an example of a lifetime. In the function, the longest, it's taking a lifetime generic. You can see the tick A is the named lifetime. And then the parameters are x, which is taking a reference to a string, which is a string slice, and the string slice has a lifetime of a of tick A, and the y has the same lifetime, and it is also a string slice. The function returns the another string slice with the tick A as its lifetime. The important thing is that as a reader of this function signature, it is already clear to me that the lifetimes of the parameters that are passed in and the return value are effectively the same. That means it is returning a part of x or y or both, and I don't even need to go into the code. This can be extremely handy when we are dealing with borrows and references from the caller code. And there are a lot of compile time checks that can be done if this type of declarative way of specifying lifetime is done. And then let's talk very briefly about traits. Trait summary, and it has a function summarize, which takes reference to the self, which is a object, and it returns an owned string. So what is going on here? We can think of trait as an interface in Java. It does not have to have a body. It is simply declaring that the structs that use this trait have this method summarize implemented for them, and that is a guarantee. This allows for multiple inheritance patterns, which is not possible in Java. Next, let's look at the fearless concurrency. Ownership rules prevent data races between threads. Use move closures to transfer ownership into threads. Threading is a very big topic in Rust, but let's just go briefly over how to create a thread. A thread can be created with thread spawn, and it has a move closure, and it is taking no parameter. So the two pipe symbols means it does not have any parameter. It's an empty parameter closure, and the body of the closure simply prints the variable v, which is defined outside the scope of the closure. And the handle.join merely waits for the thread to complete, and once it completes, it unwraps it. So it is a very simple function that allows us to transfer ownership of the variables from outside the scope. In this case, the variable v. That's it, folks. Thank you for listening.